Now, really quickly, if you look at the periodic table, you don't actually see mass numbers on the periodic table. Instead, you find atomic weight. And that's because we actually sum the weighted average of all of the different mass numbers. So, for example, if you have 75.78% of chlorine 35 and 24.2% of chlorine 37, meaning 75% of the naturally occurring chlorine is chlorine 35 and 24% of the naturally occurring chlorine is chlorine 37, what you're going to do is take a weighted average. So to do that, what you do is you convert the 75% to a decimal, so 0.7578, and you multiply it by its atomic mass, which is 34.969. The 35 is just a rounded value. Then you're going to add to that the percent of chlorine 37, which is 24.22%, but make that into a decimal. So it would be 0.2422 times the atomic mass. And then you add those together, and that gives you your atomic weight. And so that explains why the values that are given to you on the periodic table can sometimes, for example, for chlorine, be almost halfway in between mass number of chlorine 35 and chlorine 37. So that explains why the atomic weight, or the average atomic mass of chlorine, is not 35 or 37, but instead 35.453. So if we look at this problem, instead of me asking you to find the average atomic mass, what I'm doing now is saying, all right, what is the percent abundance of each isotope if I know the average atomic mass? So what I'm going to do is I'm going to take the first mass, which is 24, and I'm going to multiply it by its percent abundance, which we don't know, so we're going to call that X. Then I'm going to add to that the mass of the next isotope, which is 26, times its percent abundance. Well, if the percent abundance of magnesium 24 is X, then the percent abundance of magnesium 26 is going to be 1 minus X. So it would be 24X plus 26 times 1 minus X. Now it's 1 minus X, not 100 minus X, because remember, when you find your average atomic mass, you are using the decimal version of the percent, not the percent itself. And so that is going to be equal to your average atomic mass, which was 24.31. So with a little bit of math, I'm going to distribute the 26, then I'm going to isolate my variable. I find that my X is 0.845. And so since this question asks for the percent abundance of each isotope, I know that the percent abundance of magnesium 24 is going to be 84.5%, which means that the percent abundance of magnesium 26 is going to be 15.5%, because they need to add up to 100%.